Hello, geometry folks, and welcome to Chapter 10, Circles. So today we're going to take a look at some properties of tangents. That is what we are going to focus on today. However, we need to have some vocabulary for the foundation of what we're doing today, vocabulary on circles. And then we're going to spend the next couple of weeks talking about circles. So you'll need to get your guided notes out, a pen or a pencil, and a calculator. And we'll begin with circle vocabulary. So a circle. A circle is a set of all points that are equal distance from the center. The center is the point in the middle. The radius is the distance from the center to the circle. The diameter is the distance across the circle, and it has to pass through the center. Now those four definitions you're probably fairly familiar with. The next three you might be new to you. So a chord. A chord is a segment whose endpoints are on the circle. A secant is a line that goes through the circle. And a tangent is a line that intersects a circle at just one point. Now, these definitions need to go in your notes. And we are going to take a look at the visual of these on the next slide. So if the definitions aren't really making sense to you, you're going to see a visual now. So I want you to add these to your circle. So the curve all the way around the circle, the black stuff all the way around, that's the circle. The point right here is your center. Okay, and then you want to label all the other parts. Now, radius is from the center to a point on the outside of the circle. The diameter is a segment that goes from one point to another point, but must go through the center point. Okay, and then a chord. Here's what a chord is. A chord is a segment that goes from one side of the circle and has an end point. That's an end point. And then it goes through to the other side of the circle, to the other end of the circle, and has another end point. Okay, so a chord has two end points. A secant is a line. So notice a line goes on forever. So even though it does touch the circle at 2 points, those are not end points because it's a line. So a secant is a line and a chord is a segment. Okay? And then a tangent is also a line. Okay? And it is on the outside of the circle and it only touches the circle in one point. That's called the point of tangency. So it only touches the circle on the outside one time. Okay, so that is a visual representation of all of those words. So hopefully that helps with the definitions. Now you're going to tell me whether the line or the segment is best described as a radius, a chord, a diameter, a secant, or a tangent for circle C. Now we call it circle C because the center is point C. So this is circle C. All right. Segment DC would be a radius. So D to C, that is a radius. Segment B to D, that would be called a chord. B to D would be called a chord, not a secant. I'm sorry about that. That is the wrong word. This would be a chord because it has endpoints. Okay? If it was line BD, then that would be a secant. Okay. Sorry about that. Okay. Then DE, line DE, okay, that's going to be a diameter. And AE, that's a line that goes through A and E, and that's on the outside. That would be called a tangent. Okay, so make sure that you know what parts represent each part of the circle. All right. Now let's talk about a tangent. A tangent is to touch at one point. Typically, a line is tangent to a circle. A common tangent is a line, array, or a segment that has two or more circles sharing a tangent. Okay, so if I were to draw two circles here, this would be called a common tangent because this tangent goes through at that point, and this tangent also touches another circle. So that would be called a common tangent. This tangent is a common tangent because it touches the smaller circle and the larger circle, and it's one line, so it would be called a common tangent. How many common tangents do you see in these four diagrams? So let's first look at diagram A. That would be a common tangent, and it would touch the circle here and the smaller circle here, so that would be one common tangent. Where else could I draw a common tangent? I could also draw a common tangent there, where it would touch the larger circle here and the smaller circle here. So this one would have two common tangents. How many common tangents could I draw in figure B? Well, I could draw one there, and it would touch the circle there and the smaller one there. Okay, oh, there's another one. It would touch there on the larger and there on the smaller. I could probably also put a common tangent there in between and two different ones in between, because this tangent will touch the larger circle here and the smaller circle here and the larger circle here and the smaller circle here. So this one would have four common tangents. If I look at figure C, I could have a tangent on the outside, another one on the other outside, and I could put a tangent right in the middle where it would touch both the circles right at the same point, but on different circles there. And then on figure D, so figure C, excuse me, would have three common tangents, and figure D would have one common tangent where it would touch both the circles right there. So that would have one common tangent. Okay, so that's tangents. Now let's talk about concentric circles. They're circles that share the same center. So if I have a center here, this circle, that would be its center. Okay, this center would also be this circle's center, and so forth and so forth. So concentric circles are circles that share the same center. Okay, now I have a figure where AB is tangent. It's a tangent, okay? And the point of tangency is B, okay? And you want to calculate the radius. Well, the radius is from the point on the outside of the circle to the center of the circle, so that's why we labeled that R. We have a 90-degree angle, so we can use the Pythagorean theorem. R squared plus 12 squared is going to be equal to all of this side. Well, this side is actually R plus 8. So it would be R plus 8 squared. Okay, so we get R squared plus 144, because 12 squared would be 144, is equal to R plus 8 squared. Now, if you remember that from Algebra 1, that means R plus 8 times R plus 8. And if we have two binomials, we can use the double distributive property. R times R is R squared. R times 8 is 8R. 8 times R is 8R. And 8 times 8 is 64. Okay, now I will subtract the R squared from both sides. And look at there, they cancel out. That's nice. I have 144 equals 16R, because all those together make 16R plus 64. Now I can solve for R. Subtract 64 from both sides, and I get 80 equals 16R. Divide by 16, and I get r equals 5. So the radius of this would be 5. Okay, and we will be using tangents and Pythagorean theorem in our practice tomorrow. Tangent segments to a circle from the point outside the circle are congruent. So what this says is that if you have two tangents and they come together at a point outside the circle, okay, this point is point S, but they're both two different tangents, but they hit the same circle, we will call them congruent. So those two segments will be congruent. Now this is also going to be helpful for us when we have to solve a circle for x. So I know that these two are tangents that meet at point J, and so this segment and this segment are congruent. So I can say 5x minus, oops, that should say 4, is equal to 2x plus 2. And what I'm going to do is I'm going to add 4 to both sides and subtract 2x from both sides. Get the x's on one side, get the numbers on the other, and I'm going to get 3x equals 6. And then I'm going to divide both sides by 3, and x is going to equal 2. All right, so hopefully today you've gotten some good vocabulary for circles, and you also understand tangents and how we use the Pythagorean theorem, and we will continue to practice this as we continue this chapter tomorrow. Thank you, and have a great day.